Okay, so we're going to finish the notes from yesterday. We're on 3.3 linear programming. This is the story problem. How is this one different than yesterday? You have to do everything on your own, right? Yesterday they gave you x and y, they gave you the inequalities, they gave you the f of x comma y, they gave you everything, right? Today we have to come up with it on our own, okay? So let's go back to the directions. There we go. Define the variables. That means say x stands for this, y stands for that, okay? And then we're going to write a system of inequalities. Then we're going to do everything we did yesterday. We're going to graph it and find the vertices and all that, okay? I don't know why that's not working. So here's where you can call it whatever you want. Oh, you should probably read it. Sorry. Let's read it. Jenny's Bakery makes two types of birthday cakes. Yellow cake, which I think it says sells for $25, and strawberry cake, which sells for $35. Both cakes are the same size, but the decorating and assembly time required for the yellow cake is 2 hours, while the time is 3 hours for the strawberry cake. There are 450 hours of labor available for production. How many of each type of cake should be made to maximize revenue? So this is used in the real world. This is actually a very simplified version of what's used in the real world. I know it looks really hard for us, but in the real world, this type of a thing is used to maximize revenue. But there's a lot more typically things that go into it than this, but this is used. So you can only spend this much money. You don't want to waste the cake. You don't want someone coming in who wants a cake and they can't have it, because then you lose a customer. Do you see what I'm saying? So all these things are real. It's just this is kind of like an easy one. It doesn't usually come out to 2 hours exactly, right? Like maybe it's 2 hours and 10 minutes or something. Does that make sense? Okay? So we're going to call, because it's a story problem and because we're graphing it, I'm probably going to use x and y, okay? So I called x yellow cake, and I called y strawberry. Obviously, you can do whatever you want, but since we're doing it together, let's do it the same way. Now, on I step, don't call x equal yellow. That's not going to get you anything. You need to be more specific, but I just don't have room. So I would say x equals number of yellow cake, number of hours to make yellow cake. Or no, excuse me, we're doing x is number of yellow cakes made / sold, right? You would just be more specific is what I'm saying, okay? So we've done step 1. Step 2 is where you write an inequality or multiple, right? So most of you guys could probably at least write me one inequality. Let me save you some time. The money for right now, we don't use that. We use that as our f of x comma y formula, and I'll explain why later, but don't use the money right now. That's not what we're doing. So try to write just one inequality that you think we might have to graph. Okay, I'm hoping you guys at least came up with 2x plus 3y, what 450? Less than or equal to. Does that make sense to you? Okay, it's kind of like the nickels and dimes thing. And then we also have x is greater than or equal to 0 and y is greater than or equal to 0. Here's why. We can't have, so we're talking about hours here, right? You guys get that the x and the y dealing with the 2 hours and the 3 hours, right? So this is our hours, and then x and y is the number of cakes made or sold or whatever. So you can't have negative cake. Does that make sense to you, right? Now, if this was money and we were trying to figure out if they asked us this a different way, you could have negative money, right? You could lose money and then you go out of business. Do you understand what I'm saying? So if that happened, I would not use those inequalities. But because we're talking about cakes made, you can't make negative cake, okay? So what this means is we're in quadrant 1. That's what that means. That's what we talked about the other day. So x greater than or equal to 0 is this stuff. Y greater than or equal to 0 is this stuff. So they overlap in quadrant 1. So I'm not going to use quadrants 2, 3, or 4. Do you understand that? Okay? So now, if you go back to our directions, we graph this. right? So we don't actually have to graph the x greater than or equal to 0 or the y greater than or equal to 0. It's just quadrant 1. So whenever I graph something like this, I typically do x and y intercepts. That's easier for me. So to find x, you set y to 0. Good. To find y, you set x to 0. Excellent. So you guys find x and y intercepts. Does anybody have the x-intercept yet? 225. Good. Take your time and get it right. Ask me or a neighbor if it's not working for you. What about your y-intercept? 150. Good. That's easy for you now, right? Are you guys okay? Anybody not okay? Okay, great. So for us to graph that, I think I went by 25. So you have to say that, right? So if I'm on the x-axis at 225, there's 1, 2, 3, 4, there's 100. 1, 2, 3, 4, 225. If I'm on the y-axis at 150, there's 1, 2, 3, 4, 1, 20, there's 50. That's a solid line. I don't need arrows again because I'm not out here anyway. I'm going to shade below because it says if I get y alone, right, it's less than or equal to. Is that okay? Okay. So we're going to write down our ordered pairs. What ordered pairs do we have? Don't overthink that. What ordered pair is this one? 0, 150. What's this one? 225, 0. Very good. Is everybody okay with that? The other classes were asking why I didn't use 0, 0. Why don't I use 0, 0? There's no point in that, right? It's a story problem, so I'm not going to use 0, 0. That doesn't even make sense, right? You're going to make no cakes. You're going to make no money. That's not even helpful. If you want to put 0, 0 in, you can, but it's not going to get us anywhere helpful, okay? So if you go back to your notes on the front page, I don't want to keep flipping. It's hard to do on here. We have to write our own equation. We have to write our own f of x, y. That's where the money comes in, okay? Try to write your own equation. It's like that nickels and dime one, okay? Just try. You have a pencil with an eraser. If it's not right, we'll fix it. How much is it for a yellow cake? 25x. How much for the strawberry? 35y. Do you guys get that? Okay? So we plug these into our equation. So plug in 0, 150, substitute, see what you get. What do you get? 5,250, right? What about the other one? No. Yeah, 5,625. Try it again. That says 225, 0. I know it's kind of hard to see. Did you get it right? Okay, good. All right, great. Did you guys get that? So let's actually go back to what the question wants, right? How many of each type of cake should be made to maximize revenue? That's why I just want to max here. I want to maximize it. I don't want to minimize it, right? If I didn't minimize it, it would be the 0, 0, wouldn't it? I don't know why you'd want to do that, but you can. So which one is it? This one, right? But the way they ask the question says how many of each type of cake should be sold. So what would I say? How many yellow ones? 225 yellow cakes. How many strawberry? 0. 4, 5, 6, 2, 5. So again, that's kind of the hard part about math is in the real world, so we figured out mathematically the best way to fit all those restraints, okay? But in the real world, if you advertise that you sell yellow and strawberry cake and you don't make any strawberry cakes, you might get people mad. Do you see what I'm saying? So you just have to do the math. In the real world, it might have a little bit more variables in it, but right here we're just saying, hey, if you make 225 yellow cakes, you're going to make the maximized profit for the amount of hours you have to spend. Do you guys get that? Okay, great. We're going to